we are aware of the fact that there are some equations that do not end up with a correct answer. I mean, you get complex roots or you get undefined solutions. Under root of -4, math error. Every time you'll write under root of -4, you get math error because it's a complex number. So there are certain equations which are called complex equations. So our next topic of the day is complex numbers and how to solve complex numbers. So in order to enter into this mode, I will press menu and I will press 2. When I press menu and 2, you will realize that on your screen, you will get this I. This I is called iota. This iota indicates that the complex numbers can now be solved. So if I will write under root of -4 here, the answer I will get is 2 iota. So in menu 1 or the basic mode, I was getting math error. But when I have entered into a complex mode, this iota or this iota here indicates that I can solve complex equations. And when I solve complex equations in a complex number, under root of -1 is called iota. Under root of -1 is called iota. So in this mode, we can perform basic operations, that is addition, subtraction, multiplication of complex numbers. We can solve the conjugates. Conjugates means a plus b will have a conjugate of a minus b. X plus y will have a conjugate of x minus y. So if the sign before the complex term is changed, it becomes a conjugate. Then we'll try to find out what is a real part, what is an imaginary part. A complex number comprises of a real part and an imaginary part. Polar form is one of the forms of writing complex numbers, and polar form to complex number form is also what we'll be studying today. So the first thing is perform the indicated operations. 7 comma minus 9 means 7 minus 9 iota. Iota is above this button. When I press this ENG will give me iota. So 7 comma minus 9 plus 3 comma 5 is the complex number which is written in the coordinate form. So this is 7 minus 9 iota plus bracket open 3 plus 5 iota. Iota is ENG button. I will close the bracket. It is always advisable to write the complex numbers within brackets. So 7 minus 9 iota plus 3 plus 5 iota. The addition of a complex number is very similar to algebraic addition and subtraction. So I will get 10 minus 4 iota. All those people who have studied complex numbers will realize that this is the answer which we would have achieved if we would have solved it manually. Then if let's say if this would have been 7 minus 9 iota minus, so all I need to do is change the sign here and my answer now will be 4 minus 14 iota. I hope everyone is following me. If on the other hand there is a dot here where my cursor of the mouse is, this dot means multiply. So all I need to do is I will scroll right and change the minus to multiply. So this will become 66 plus 8 iota. All those people who know how to solve complex numbers manually do realize that 7 minus 9 iota multiplied by 3 minus 5 iota would have at least been 5 to 6 steps, which I am saving time by just inserting it into the calculator and getting the answer that I need to get. Similarly, when there is divide, I will just change this to divide and I will get minus 12 upon 17 minus 31 upon 17 iota. We always write minus 12 upon 17 is the real part, minus 31 upon 17 is the imaginary part. The number along with I, the coefficient of I, is the imaginary part, and the number without coefficient is the real part. A complex number is a combination of a real and an imaginary part. I hope this is clear. All right. I would also like to indicate and identify that if you multiply two iotas, you will get minus 1. If you multiply two iotas, you will get minus 1. And the reason being is iota was under root of minus 1. Remember, I told you that iota is under root of minus 1. So if you multiply under root of minus 1 with under root of minus 1, you are bound to get minus 1. So it's an indication that if you are encountered with this, it means that under root of minus 1 into under root of minus 1 is minus 1, which is same as iota multiplied by iota, which is minus 1. I hope this makes sense and I hope this is clear to all of you. In order to get iota, you have to be in menu 2. Menu 2, press menu 2. I have written it on the screen also. Press menu 2 to enter into complex mode. And the indication that you have entered into the complex mode is on your screen, this iota will be written. Iota on the screen indicates you have entered into the complex mode. And now you can solve the complex numbers. I hope this answers your question. All right. Now find conjugate and modulus of the following complex numbers. So if I need to find the conjugate and modulus of the following complex numbers, part 1 is here. Part 2 and 3 are on the next screen. I will do part 1 for you. Part 2 and 3 you have to do it on your own. So let's learn how to find the conjugate and the modulus of the complex numbers. So if you realize, the question is in the form where iota or the imaginary number is first and the real number is written second. The ideal way to write is you first write the real number, then you write the conjugate, then you write the imaginary number, because when you apply conjugate, the sign before the imaginary number changes. But the calculator is smart enough that even if you write imaginary number first, it will automatically adjust. So let's see. What you need to do is you press OPTN. When you press OPTN, it means option. What do we need to do? We need to find the conjugate. So I will press 2. The calculator is asking me, I need to find conjugate of what? So to find the conjugate, I will write this particular function, that is 2 iota plus 1, and I will close the bracket. Now when I press equals to, the calculator will give me the conjugate, that is the real part, change the sign of the imaginary part, and then the imaginary part. So if I would have written option 2, 1 plus 2 iota. Now I'm writing the real first and then the imaginary. I would still have received the same answer, because the calculator will always give you the real part first and the imaginary part. So whether you write imaginary first and real next, or real first or imaginary next, you will always end up with the same answer. I hope this makes sense. Next, you need to find the modulus. To do so, you will first write the function, that is 2 iota plus 1. Then you press OPTN and you scroll down. When you scroll down, it is writing R and theta and A plus B iota. So basically R and theta shows the polar form. Polar form means that you will get the modulus and the argument. Modulus means magnitude of the complex number or the length of the complex number. Argument is the angle that the complex number makes with the horizontal axis. I hope you are all following me. Modulus is the length of the complex number and argument is the angle that the complex number makes with the horizontal axis. So always remember, whenever you need to find the modulus and the argument, you have to do the same thing. That is, you have to press 1. So now the calculator is asking you that 2 iota plus 1 is being converted into the polar form. This is called the polar form. I will press equals to. So under root 5 is the modulus and 63.43 degrees is the argument. I hope this makes sense. Under root 5 is the modulus and 63.43 is the argument. Similarly, if you were provided with some kind of this thing, let's say you were provided the argument and the modulus, and if you wish to convert it into I form, the iota form, then you would have to press option, scroll down, press 2. So the answer will be converted into the normal algebraic form, which is 1 plus 2 iota. I hope this makes sense. So in order to find conjugate and in order to find modulus, you have to apply the functions given in the calculator. So you do not need to waste any time at all. I will move on, and you need to find the conjugate and modulus of the following complex numbers. Now I have given you some complex numbers. All right, so I'll do the second part for you guys. I will press the option button. I will press 2. So the calculator will ask me conjugate of what? So 4 iota minus 3 bracket close, and the correct answer is minus 3 minus 4 iota. I hope this is clear. Similarly, if I need to find the modulus and argument, first I will write 4 iota minus 3. I will press option button, I will scroll down, and I will press 1, and I will get both the modulus, that is 5, and the argument, that is 126.86 degrees. I hope this is clear. And for part 3, I will press option, I will press 2. I need to find conjugate of 5 plus 12 iota, and I will close the bracket. The answer is 5 minus 12 iota, which is very obvious because sign before the imaginary number changes. Then I need to find the modulus and the argument. So I will write 5 plus 12. I will write iota, and I will press OPTN. I will scroll down. I will press 1. That is 13 is the modulus and 67.38 degrees is the argument. I hope I'm clear. And the next part is we need to solve these 3 parts, and to solve these 3 parts, always realize you are told that you need to solve these 3 parts where Z1 is 1 plus iota and Z2 is 3 minus 2 iota. Whenever multiple parts are involved of the same complex numbers, my advice is always store the value in the memory of the calculator. I'll teach you how to store it. I have also mentioned it on the screen so that this is in your memories. As Z1 and Z2 will be used more than once, it will be time saving to store them separately in memory. So in order to store it, what we do is we will write 1 plus iota, whatever the equation is, 1 plus iota is the equation, and I will press this button STO. STO means store. So store the value into which value? So please realize that there are alphabets written with red: A, B, C, D, E, F, X, Y, M. I hope everyone can see these alphabets. So all you need to do is write 1 plus iota, press store, and press A. So now A is 1 plus iota. Got my point? I will now store Z2. Z2 is 3 minus 2 iota. So what I'll do is I will write 3 minus 2 iota. I will press STO and I will press B. Red wala B is this. So 3 minus 2 iota is now B. So now I have A and B stored into the calculator. Why I did that? Because I will be using A and B multiple times in this question. So since I'm using calculator as a time saving technique, I should also be knowing the other hacks that will save time. So what I did was I stored this value. Now I do not need to write the complex number a 1 plus iota and 3 minus 2 iota again and again, because the values are stored. So all I need to do is I need to find 5z1 minus 4z2. So what I'll do is I will press shift and bracket. I hope by now you are aware of the fact that shift and bracket means absolute valued functions. So absolute valued function of 5z1 which is A, so alpha A. Whenever I need to write A or B or C or D, since they are written with red, any function written with red is operational after pressing alpha. Any function written with yellow is operational after pressing shift. I hope this is clear to all of you. Minus 4 Z2. Z2 is B. That is alpha B. So 5A minus 4B is same as 5Z1 minus 4Z2 का absolute valued function. I will press equals to and I will get under root of 218. I hope everyone is following me. Alright, in part 2, Z has a dash above Z. Anything that has a dash above a number or an alphabet, it means we need to find conjugate of that. So basically we need to find conjugate of A square. So in order to find conjugate, I know that I will press OPTN. I will go to 2. Conjugate of what? Z1. Z1 is A. So I will press alpha A. I will close the bracket and it is square. So I will press square. So I need the square of conjugate A. So it is minus 2 iota. I hope everyone is following me. Alright, please also remember, if the dash would have been above square, if this would have been Z1 square dash, if this would have been Z1 square dash, it means that square would have been inside the bracket. You need to be aware of the fact whether it is conjugate of A square or is it conjugate A square. So in this particular case, it is conjugate A square. So please be very vigilant with what you are performing. Then part 3 is Z1 upon Z2. Z1 upon Z2 is complex number Z1 divided by complex number Z2. For our calculator, it is A divided by B. So all I will do is I will press alpha A divided by alpha B. And I will press equals to, so 1 upon 13 plus 5 upon 13 iota. 1 upon 13 is the real part, 5 upon 13 is the imaginary part. I hope I am clear. Alright, I'll tell you how to store values. Let's say I want to store the value of C as 2. So I will write 2. I will write store and I will press C. C is written with red. So the button that is representing C is this. So it means that the value of C is stored as 2. Let's say I want to store the value 5 iota. So I wrote 5 iota. I pressed STO. STO is next to ENG. Here is STO. I press STO. I press D. So now D is stored as 5 iota. Let's say I want to store 3 minus 4 iota. So I will press 3 minus 4 iota. Then I will press store. I will press E. So E is 3 minus 4 iota. I hope you get this. Similarly, let's say I want to store minus 1 minus iota. So minus 1 minus iota, I want to store it. So I will press STO and I will press, let's say, F. So F is minus 1 minus iota. Now let's say I wish to recall what I have stored in which variable. So I will clear my screen. I will press shift and I will press STO. When I press shift and STO, look what is written with yellow, recall. So it will recall everything. So I have stored A as 1 plus iota. I have stored B as 3 minus 2 iota. I have stored C as 2. I have stored D as 5 iota. E as 3 minus 5 iota. F as minus 1 minus iota. M I have not stored anything, so it is 0. X I have stored as minus 4. Y I have stored nothing, so it is 0. So I hope you now realize how to store and how to check what is stored. And if I wish to clarify this, I wish to clean this screen, all I need to do is press shift, press 9, press 3, press equals to, and press AC button. We have discussed this also, that it initializes all the memory. Everything in the memory of the calculator is deleted. Let me prove. Press shift and press STO. Now please realize all values have been removed because I initialized the calculator. I removed all the memories of the calculator. I'll just immediately solve this. I want everyone to focus on the screen so that you can understand how we managed to do this. I opened up the bracket, 2 minus iota, that is ENG button. I closed the bracket. I pressed the power button. I wrote 4 and I pressed equals to. So minus 7 minus 24 iota is the first answer. I hope this is correct. The second is a fraction. So I opened up a fraction, 1 plus iota upon 1 minus iota. I will come out of the fraction, multiply. I will write another fraction, which is 2 minus iota upon 1 minus iota. And I will press equals to, and I got minus half plus 3 upon 2 iota, which is also minus 0.5 plus 1.5 iota. This SD button will help you convert from fraction to decimal and decimal to fraction. I hope this is correct also. Then the next part is 2 plus iota, the whole thing square. I hope you are realizing the fact why in this particular question I have not stored the values. The reason being, all parts have different values. If the same values were being used in all the parts, I would have stored the value earlier. But since all the values are being used are different, there is no need to waste time and store the values. So you need to be smart enough to realize when to store the values, when not to store the values, when to apply which feature and why. 3 minus 4 iota, bracket close, 2 plus iota, the whole thing square, upon 3 minus 4 iota, and the answer is minus 7 upon 25 plus 24 upon 25, which is minus 0.28 plus 0.96 iota. Now this is the question which says find the imaginary part and the modulus of this. So fraction 1 plus iota upon 1 minus iota, come out of the fraction, multiply fraction, that is 2 minus iota upon iota plus 5, iota plus 5. And when I press equals to, I got 7 upon 26, which is the real part, 9 upon 26 iota. So the imaginary part is 9 upon 26. And now I also need to find the modulus. So what I'll do is I will press OPTN, I will scroll down, I will press 1, and I will get the modulus as well as the argument. I hope this is clear. Let's check the answer. 9 upon 26 is the imaginary part. I only have the answer of imaginary part, which is 9 upon 26. We got the same answer. See, 9 upon 26 iota. The number with the iota is the imaginary part. The number without iota is the real part. I hope this is clear. And in order to find the modulus and the argument, you press option, you scroll down, you press 1, and you are done with it. So root 130 upon 26 is the modulus, 52.125 is the argument. I hope I'm clear. I hope everyone is understanding this.